Did you study matrices last year?
Yeah.
Well, good. Then you know, I listed some vocabulary there. I want you to definitely know the definition of a matrix. These other terms we'll talk about as we come to them. But a matrix is a rectangular array of numbers arranged in rows and columns. So a rectangular array of numbers arranged in rows and columns. And on the next page, I'm just going to pick, I've got some matrices listed there. So I'm just going to write down D. This is matrix D. And I'm going to kind of use it to help explain a few of the other words in there. Obviously, if you look at that string of matrices in number 2, they're not all the same, right? They're different sizes, and the size of the matrix is called its dimensions. So this matrix has dimensions 2 by 3. 2 rows, 3 columns. So what are the dimensions of a matrix? It's rows by columns. Rows by columns. Rows of the bleachers, columns of the White House. Rows, columns. So that's what we mean by dimensions. What do you think a square, I'm not sure why I didn't put an X on the end of that word. What do you think a square matrix is? I think I meant to say square matrices. Well, 2 by 2 would be square, but so would 3 by 3. Any matrix that has the same number of rows as columns, just like a square room would be 10 by 10. That's what a square matrix is. The numbers inside the matrix, so the matrix is full of numbers. These are called the entries, also called elements. These are the entries and the elements of the matrix. If I, for some reason, am talking to someone on the phone and they can't see my paper and I want to talk about that number, for example, I would refer to it like this. First of all, I would use a little d because the lowercase d says I'm a member of matrix D. And then the 2-1 says I'm the element in matrix D that's in the second row, first column. That's not a 21, that's a 2-1, second row, first column. So if I look at matrix D, and I look at the number that's in the second row, first column, it is 5. Would you agree with me?
Yep.
So what is, that's not what I meant. I meant 1, 3. What is D sub 1, 3? What would that mean? That, be careful. First row, third column would be this guy, wouldn't it?
Yeah.
That's 3, yeah. So that's what that notation means. Capital letters for matrices, little letters for entries. If we multiply a matrix by a number, so for example, if I said 2D, we're going to talk about how to do that. You probably already know. It's really easy. It's obvious. It's what you think. But the 2 is referred to as a scalar. A scalar is simply a real number quantity. So if you study in physics, you talk all the time about vectors and scalars. And a scalar is just a number. So in regular math, we would call that a coefficient. But in matrix land and vector land, it's referred to as a scalar. So a scalar is just a real number. The rest of those we're going to talk about as we come to them. So let's get busy and do some actual problems here. The first one says A plus B. You want to take a wild guess? A plus B. Think you can do it? And what you guess is going to be right, guys, because there's only, it makes perfectly good sense. It's the obvious thing to do if we're going to add A and B together. 1, negative 2, 3, and 5. And 6, 3, 0, and negative 4. What number's going to go right here?
7.
Yep. And this is going to be a done. How do you add matrices? You add their corresponding entries. Now, that means what about adding matrices? Can I add any two matrices? Can I just pull two random matrices out of the pile and add them together? They gotta have the same dimensions, that's right. They gotta have the same dimensions. So you cannot add matrices unless they have the same dimensions. But if they have the same dimensions, adding them is a piece of cake. A plus 2B. Well, this is going to be exactly the same thing, except now we've got a 2 out in front of that B. Well, how do you think we handle that? What do you think I do with that 2? I heard somebody say distribute it, and that's exactly right. So it's going to be a 12, 6, 0, and negative 8. Mrs. Ford, is it that easy? Yes, it is that easy. Jesus?
So like, when you come up with that answer, would it be like, would that dimension be AB?
Would that what be now?
Since you know how it says like A equals like that dimension, would that other dimension like, we add these together, would we do like AB equals, like the A?
Oh, no, it would just be A plus B. And that's a new matrix. You could give your new matrix a different name, but that would be A plus B. And this one is going to be A plus 2B, so it's going to be 13, 4, 3, and negative 3. So that his name is A plus 2B, unless you give him a different name, like Q or something. Yep.
Does this work with like multiplication?
We haven't multiplied yet. We're going to in a minute. Let's take it one step at a time. How about C? What about C? Can't do it. So you just say can't do, or you put an empty set. It's not doable, because what about A and D? A is 2 by 2, and D is 2 by 3, so they're not addable. Now, Jacob's been dying to do multiplication. That's what D is talking about. D is talking about multiplying A times B. Now, multiplication is done differently than addition. So first, I want to make sure that I copied it right, and then I want to make sure you understand when you can multiply. We agreed that we can't just reach into the matrix pile, pull out 2, and be guaranteed to add them. The same is true of multiplication. You can't just reach in and multiply any 2 matrices. However, the rule is different. If you want to multiply 2 matrices, write down the dimensions of each. So this one is 2 by 2, and this one is also 2 by 2. All that matters in multiplication is that these 2 numbers match. The middle numbers must match. So you could have an 8 by 7 and a 7 by 12 and multiply them. They would be multipliable. The rule for multiplication is write down the dimensions and the middle numbers have to match. So the number of columns of matrix 1 has to match the number of rows of matrix 2. Okay? The other dimensions, the outside ones, give you the size of your answer. So this answer is going to be another 2 by 2. These must match. These give me the dimension of the answer. So in my example over here, where I had an 8 by 7 and 7 by 12, my answer would actually be an 8 by 12. Okay? Now, how do we get the numbers in there? Well, it's really easy, but you kind of have to develop your own system. This number right here that I have to find, these are the blanks. These are blanks for the numbers. That number is in the first row, first column. Would you agree with that? So when I multiply, I am going to take the first row times the first column. Everything we do is row first, then column. So it's the row times the column. So the way I do it, and again, you'll develop your own system. I write down the numbers in my row, 1, -2, and I spread them out. Then next to those numbers, I put the numbers in the column, 6, 0. Everybody still with me? Now, I'm going to multiply the pairs and add them up. And that's the number that's going to go in this spot. So that's going to be what, 6? Now, guess how I'm going to fill that blank? Same thing, but I'm going to use the first row and the second column because that's the position that I'm in right here. So I'm now going to use my first row and my second column. So there's my 1 and my -2 again. And then I have 3 and -4. So you multiply each pair and add them up. So that number is going to be in 11. Okay, can you do this one? You're going to use the second row and you're back to the first column again. So multiply your second row times your first column. Tell me what you get in that blank. Anybody? Got a number yet?
Is it 18?
It is 18. Thank you. Did everybody get 18? Did anybody get 18? Anybody not get 18? You didn't get it? You did? All right, let's fill in the last one. What's the last one?
Is it -11?
I think it is -11. Very good. Very good. It's easy, but you got to be really organized, and it's easy to make mistakes too. All right, how about D times C? So the next problem is D times C.
All right, I have things for
All right, put them on. All right. This will be our last problem, guys, and then you're going to be on spring break. Yay! Let's do D times C. First of all, can I even multiply D times C? Are they multipliable? Yes. This has 2 rows and 3 columns. Remember, rows go this way. Rows of the bleachers. Columns of the White House. This one is a 3x3. These match. As long as those match, it doesn't matter what else you have. You can multiply. The answer is going to be another 2x3. Right? These give me the answer. Now the process, yes?
If it was C times D, would you be able to flip it to multiply it?
No,
Or
no.
do you have
C
to-
times
as
D,
order
you
math?
gotta stay in the order that is presented. Okay? Otherwise, it's a different problem. Matrix multiplication is not commutative. All right, so here we go. We're gonna fill in this spot, which is where? First row, first column. So we've got more numbers, but we do it exactly the same way. So I write down my first row, 2, -1, 3. And then my first column, 1, 0, 1. And then I add them up. So I think the first number is 5. And then, it doesn't matter what order you go in, but I usually go across this way. This is the first row, second column. So first row, oops. There's my first row again. And now my second column, seven. It's easy to make an arithmetic mistake. Did I check that okay? Hector, are you nodding or shaking? Is that right? Okay. All right, and then finally, first row, third column. And that is 5. Watch all those negatives. You have to be really careful about all that. All right, let's get the bottom row done and then you're finished. Here we go. Bottom row. 5, 1, 4. All right, what did we come up with? This one's 9. First one's 9 too. And the middle one
14.
is 16, 19, 14. Does that look okay? All right. What was that? That was D. Let's see, there's your one and thank you. All right, let's wait for our blessing.
I think